This is Professor Darif Seitz. This Java tutorial is Exceptions, Part 2, an overview of exceptions. Exceptions are, as we saw in the last tutorial, they disrupt the normal flow of control and they require some handling or fixing. The concepts involved are shown in this diagram. An important concept is the call stack. The bottom of the call stack, you can see this stack of books here, represents the call stack, is the original place where you're trying to do some code by calling some other methods, other functions, and they in turn call other ones, and you're calling and calling and calling. Normally maybe not this many, but this gives you the idea. So at the very top of the call stack is the current function that you're in, and when that one returns, it returns back this way. So that's the concept of the call stack. It's called a stack because, like books, you stack one call on top of the other, and to return you unstack them to unwind back down where you started. So we see here the call order. This blue arrow here is the order of the calls. In Java, with the exception handling mechanisms, there's some keywords in Java. The keyword try is when you want to try some code and you put it in a block, and if an exception happens in that block of code, you want the ability to handle not just perhaps any exception, but particular exceptions. And so you put a try block around the code that you're interested in managing for exceptions. And when you catch exceptions that are thrown out of that code, either immediately at the level you're in or down through the call stack somewhere else and returning back to you, when you catch them, you have to have catch blocks that follow the try block in the code. So the call order goes this way, and if an exception occurs somewhere in the call stack, then what happens is the runtime, the way it works, is it reverses back down trying to find a catch handler to handle the particular exception that was thrown. So the search for a catch handler proceeds back the other way, and the first one it finds that can handle this exception will be given the execution to run. This is called exception propagation. At the end of a catch handler running, there's also a finally keyword, which is another block. The finally block, when you're dealing with a try catch finally structure, will always run regardless of whether there were exceptions or not. If there were no exceptions, the try code will work and then the finally block will run. If there was an exception, the try code will be interrupted somewhere in it, and at that point where the exception occurred, the catch clause, wherever it is, the catch block will take over, and then when it's done, the finally block, which is an optional block, will take over. So it's important to have this understanding of how the calls can stack up and how the exceptions propagate back up from the current point, finding an appropriate catch handler. This class diagram illustrates the main exception hierarchy in the Java class library. Of course, at the very top we have object. Next is a class called Throwable. It has three public functions of interest regarding exceptions. Get message returns a string that describes the message, describes the exception. Then there's a print stack trace, which will print out the call stack from the original point of call, stacking up the calls through the current function where the exception occurred. And lastly, there's a toString as well. These are the main functions used in exception handling. Inheriting from Throwable, we see exception itself right here and error over here, those two classes. From exception, there is runtime exception, and those are the main three exception classes: the exception class, the error, and the runtime exception. Underneath runtime exception and error, there are many other classes that inherit from them, just as from exception there are other classes that inherit from it that are not under runtime. The groupings here, the exceptions that include error and its children and runtime and its children, all those are called unchecked. The Java compiler does not require that they be caught or that they be specified in the source code, and you will not get syntax errors for any exceptions that are of these types. Exception itself and any of its subclasses, however, are checked exceptions, and the rule is for them that they must either be caught in a handler, and if they're not caught, they must be specified as being thrown from functions where they can occur. Unchecked exceptions generally involve things that are problems in the program, logic problems, programming problems, things that need to be fixed in the program. So it's a good thing for the program to blow up and not continue to go on in a state that could cause undiagnosed damage. Whereas checked exceptions usually are things that the program should not crash, but rather should be able to handle. So this gives us our sort of an overview, a big picture of exceptions. And there'll be another tutorial on the exceptions that will look at their use, how they're try and catch, and the different syntactical elements that we've talked about here are used in an actual program.